Let us quickly solve this problem. Determine the magnitude of P in the diagram above. Now, we all know that we are going to be using the principle of moment to solve this problem. Now, but there's a problem here. This force P is applied at an angle here, an angle of 30 degrees to the horizontal. The meaning of that is that it has a tendency to move this body upward like this. Let me represent that by Py. And it has a tendency to move the body horizontally like this. Let me represent that with Px. Now, but the question is that which of these force will try to rotate this body? Because we are talking about moment, that is turning effect. We don't want a force that will move the body on a straight line. We want a force that has a tendency to rotate this body. So between Py and Px, which of the force will tend to rotate this body? Now, if this is the body, Py moving up like this will rotate the body, but Px horizontally like this will not rotate it. It will rather move it on a straight line like this. So we don't want that. Now, how do we get our Py? And that is why we normally talk about resolving a force into components. Now, this Py is called the vertical component, and this Px is called the horizontal component. Now, the component that you are going to need will depend on the topic you are. But in this topic, you are going to be needing the what? The vertical component. You are going to need the vertical component. So, how do we get the vertical component? Now, let me bring this here so that we can find our vertical component of the force. We have this, we have this, and we have this. So this is our P here. Now, but you know that the force we need is this vertical component here. Well, let us put this Px also here. Now, our angle is 30 degrees, but let me put theta. Later, I'm going to put the value. Now, this vertical component here, I can bring it here like this. I can bring it here like this. So, which represents my Py. Now, if you can remember your now, we need Py, right? We have P, and we have the angle. So that is, and this Py is opposite because it is facing the given angle, and this is the hypotenuse, right? So opposite and hypotenuse, opposite hypotenuse. So we're going to be using sine. So you can say sine theta equals to opposite, which is our Py, over hypotenuse, which is ordinary P. So if we cross multiply here, we're going to get Py times 1 is Py equals to P times sine theta, that is P sine what? P sine theta, right? So that means this vertical component that is trying to what? Rotate this body is P sine theta, right? So now let me try to redraw the diagram here like this. So we have this diagram like this. Here, we have a body here like this. And the weight of the body is 40 Newton, right? So from here, the distance is 20 centimeter, right? And from this point, now remember that this Py is what we are going to draw now, because we have found the component. So this is our Py. This is our Py. And what is our Py? Our Py is P sine theta. So I can put what here? P sine theta. Can you see? I can put my P sine theta here. So now, but the thing is this. Remember that our theta here is 30 degrees. But what I want to show you is that anytime you have a situation like this, your vertical component is always going to be P sine theta. But it may not be 30 degrees, it may be 60 degrees, it may be 50 degrees. So that is what you are going to get. So you don't need to be doing all of this next time. So because I have my theta to be 30, I will only say P sine 30 degree. So here like this, the distance from here is like this. So from this point here to this point is 30 centimeter, right? Good. So now the next thing is to apply the principle of moment. The principle of moment. Now, if you are going to apply the principle, what does it state? It states that the sum of clockwise moment about a point is equals to sum of anti-clockwise moment about the same point. Now, this is, we are taking moment about this pivot here. We are taking moment about this point. So meaning that this is the pivot here. So this is a point of rotation. This is where the body can move about. So this is the place we are taking the moment about. Now, we are not going to, we have how many forces? We have this and we have this, right? Now, if you cover this force like this, look at the direction. It's trying to move the body like this, meaning that it's trying to move the body in a clockwise direction, right? So now, if you cover this one and you look at the direction of this like this, so it's trying to move the body in an anti-clockwise direction. So this, we are going to find the clockwise moment for this force and anti-clockwise moment for here, and both of them are going to be equal to each other, right? So the clockwise moment here is going to be the force, and what is moment? Force times perpendicular distance. So the force is actually 40 here, right? So what is the distance of this force, the perpendicular distance of this force from here? So here, from here to here is 20 centimeter, right? So, but we are going to be using meters, right? So 20 centimeter, if you are to change 20 centimeter to meter, that's going to be 20 divided by 100, right? So that's going to be 0.2 what? Meters. So we're going to say times 0.2, right? Then that is the only clockwise moment that we are going to have here, equals to anti-clockwise moment. It's also 1. So clockwise moment equals to anti-clockwise moment. Now, the force here, don't forget, is going to be what? Is P sine 30, right? P sine 30 degree times distance. Now, what is the distance of this force from the turning point? So this is the force, this is the turning point. Now, don't think that because they did 30 centimeter here, remember we are taking the moment about this point. So the distance of this force from here is going to be the 20, is going to be the 20 of here plus the 30 of here, which is going to be 50 centimeter. So 50 centimeter now divided by 100 equals to what? 0.5 what? 0.5 meters. So that's going to be times 0.5, right? So here now we're going to have, that is 40 times 0.2, that's going to give us 8, equals to P times sine 30 degree is half, so that is 1/2 times, here I'm going to change this 0.5 to what? 5/10, right? So 5 here 1, 5 here what? 5 here 2, right? So I'm going to have 8 is equals to P times, that's going to be P over what? 2 times 2 is going to be 4, right? So if I cross multiply here, so my P is going to be equals to what? P times 1, that's P. 4 times 8 is what? That's 32. So I'm going to have 32 newtons. So the magnitude of P is going to be 32 newton. Thank you.